Hello everybody, welcome into another lesson. So today we are going to continue talking about conic sections, particularly parabolas. Now in yesterday's lesson we talked about parabolas when the vertex was at the origin. Today we're going to deal with parabolas when the vertex is not at the origin. So in general, the general form for parabolas, the conic section version, is one of these two formulas. So you have x minus h squared equals 4p times y minus k. If we remember, your linear variable tells you which axis the parabola has symmetry with, which axis it's on. So this first formula here is going to be if it has y-axis symmetry. So if the center is at the origin, well, x minus 0 squared is just x squared. 4p times y minus 0 is just 4py. So this is really the full general formula. Your vertex is at the coordinate hk. This is derived from when we went all the way back to when we did quadratic functions, when the equation standard form of a quadratic equation is y equals x minus h squared plus k. That's derived from that. So that's where that comes from. Now your focus, of course, if we remember right, you have to find the value of p, and then you add p to whichever coordinate has the symmetry, whichever axis has the symmetry. So in this case, it's y-axis symmetry, so you would add p to your k coordinate. And then for your directrix, it's going to be the negative of p. So my directrix would be y equals k plus negative p or k minus p. And then there's the other form where you have y minus k squared equals 4p times x minus h. Again, your linear variable tells you which axis the parabola has symmetry with. So in this case, since x is the first degree variable, it would have x-axis symmetry. And the vertex is still at hk. That hasn't changed. And you still find your p, but this time you're going to add p to your h coordinate for your x. You'll add that to your x coordinate. Your focus will be at h plus pk. And then for your directrix, it'll be x equals h plus the negative of p or h minus p. So let's get into some examples here. So let's say we have the quantity of x plus 1 squared equals negative 8 times y plus 2. Alright, so we have x plus 1 squared equals negative 8 times y plus 2. Well, first thing, let's find the vertex. Let's always start there. To find the vertex, you'll set each of these equal to 0. So set the x plus 1 equal to 0, you get x equals negative 1. So the x coordinate is going to be negative 1. Your y coordinate, set y plus 2 equal to 0, you get y equals negative 2. So the vertex of this parabola is located at negative 1, negative 2, which would be right down here. So there's the vertex of your parabola. Now, what type of symmetry does this have? Well, y is the first degree variable, so it has y-axis symmetry. It's going to mimic, basically, if we were putting it on the y-axis, only it's not going to be directly resting on the y-axis since the vertex isn't there. Now, your coefficient, let's find the p. So set 4p equal to negative 8. What do you get? Well, you get that p equals negative 2. if we remember, if your P is negative and you have y-axis symmetry, it's going to open downward. So this is an important piece of information. It opens downward. Alright, so we now have our vertex. We know it's going to open downward. It's got y-axis symmetry. Now let's find the focus. To find the focus, you're going to add that -2 to your y-coordinate of -2, which means your focus then would end up being at -1, -4. That's exactly where your focus is going to be, at -1, -4. So let's go ahead and label the focus here at -1, -4. Okay. Now what about your directrix? So what are we going to do about the directrix? Alright, well, it's got y-axis symmetry, right? So that means your directrix is going to be in the form of y equals. Now take your y-coordinate of -2, subtract or add that negative of p. Well, what's negative of -2? That's +2. So if you add 2 to -2, you'll get 0. So your directrix is y equals 0, which would just be the x-axis if it's y equals 0, right? Okay, so now we know the directrix, we know the focus, we know the vertex, we know which way it opens, what axis it's symmetrical with, and all that. We can go ahead and graph this. So let's find some points here. So if x is 0, what are you going to get if x is 0? That's an important one to have. So that would give you 1 equals -8 times y plus 2, which means y plus 2 would equal -1/8. So that means y would have to equal -17/8, which would be -2 1/8. So when x is 0, you'll be at -2 1/8. So that'll put you right there roughly. Now let's say I pick x equals -2. -2 plus 1 is what? So if x equals -2, let's put that in. -2 plus 1 squared would equal -8 times y plus 2. Well, that would give me -1 squared equals -8 times y plus 2, which means 1 equals -8 times y plus 2. So then y plus 2 equals -1/8, which would have to mean that y also equals -17/8. So I would also get the coordinate -2, -2 1/8. So there's that point. Now, why don't we go one more out? Let's do one more coordinate in each direction for x. Let's say I pick x equals +1. So I would do 1 plus 1 squared equals -8 times y plus 2. 1 plus 1 squared, that's 2 squared, equals -8 times y plus 2, which would have to mean -8 times y plus 2 equals 4. So y plus 2 equals -1/2, which means y would equal what? So -4/2, that'd be -5/2. So y equals -5/2 is -2.5. That'll put me down here. And then the same if I put in -3 for x, I would get the same thing. So now we can go ahead and proceed to graph this. It's going to be a nice fat parabola. And there is the graph of the parabola. So there's your parabola with the vertex at -1, -2, focus at -1, -4, directrix at y equals 0. All right, what do we got next? We have y minus 2 squared is equal to the negative of x plus 3. Alright, so we have y minus 2 squared equals the negative of x plus 3. Well, let's find the vertex first. So the vertex is, let's set your x equal to 0. So if you set your x plus 3 equal to 0, you would get x equals negative 3. So the x coordinate's negative 3. Now set your y minus 2 equal to 0, you get y equals 2. So the vertex of this parabola is going to be at the point negative 3, 2. So there's your vertex right there. Alright, so now we've established our vertex. And what variable is linear in this one? It is x. So x is linear, that means it's going to have x-axis symmetry, which means it'll mimic being on the x-axis. Alright, now let's find p. So set your 4p equal to your coefficient of negative 1, which means p equals negative 1/4. Now your p is negative and it has x-axis symmetry, that means it opens to the left. So this is going to open to the left. So that's also an important piece of information. Now, we got that, let's find the focus. So the focus, we're going to have to take our x-coordinate, since it has x-axis symmetry, take negative 3 plus negative 1/4. That would give you negative 13/4. And then you leave your y-coordinate alone, that would be 2. So your focus is negative 13/4 2, which would be negative 3 1/4 2, which very small distance from the vertex, right about there. Let's find the directrix. So let's get your directrix here. If it has x-axis symmetry, that means that it's going to be in the form of x equals. Now take negative 3 plus the negative of p. Well, negative 1/4 is plus 1/4, so that would actually, the directrix would be x equals negative 11/4, which would be negative 2 3/4. So there's your directrix right there. So yeah, very small distance between the vertex and directrix and vertex and the focus. So now that we have all that, we can proceed to graph. So let's pick, let's actually go for y equals 0. No, y equals 2. We already got that. We already got that. How about when y equals 1? So let's pick y equals 1. So that'd be 1 minus 2 squared equals negative of x plus 3. So this would give you negative 1 squared equals the negative of x plus 3, which would have to mean then that negative of x plus 3 equals 1, so x plus 3 would equal negative 1, so x would have to equal negative 4. So you would get the point negative 4, 1. So you would end up getting the point negative 4 for x and then 1 for y. Let's see now, what about when y equals 0? Let's pick y equal to 0. Alright, so we'll set y equal to 0. That would give you 0 minus 2 squared equals the negative of x plus 3. Well, that would end up giving you, of course, then negative 2 squared equals the negative of x plus 3, which means the negative of x plus 3 equals 4. So x plus 3 would equal negative 4. That means x would have to equal negative 7. So you would get the coordinate negative 7, 0. So 4, 5, 6, 7. So negative 7, 0 would be a coordinate. Now, what about if I pick when y equals 3? Let's pick y equals 3. It's basically, for these type of parabolas, you want to go a couple below the vertex coordinate of the y coordinate of the vertex, and a couple above it. That's basically what you want to do. That's basically what I'm doing. So let's pick y equals 3. So you would have 3 minus 2 squared equals the negative of x plus 3, which would give me 1 squared equals negative of x plus 3, which gives me negative of x plus 3 equals 1. So x plus 3 equals negative 1, which would give me x equals negative 4. So I would also get the coordinate negative 4, 3. So at negative 4, I also get a y coordinate of 3. So there's that. And for good measure, let's pick y equals 4. Let's do that. So let's take 4 minus 2 squared equals the negative of x plus 3. Alright, so this would give us 2 squared equals the negative of x plus 3. So the negative of x plus 3 equals 4. So x plus 3 equals negative 4. So then x would equal negative 7. So I could also get the coordinate negative 7, 4. So that would put me right here at negative 7, 4. Now that I have a sufficient amount of points, the directrix, the focus, and the vertex, I can go ahead and start graphing this here. And there you go. There is exactly what your parabola is going to look like for this form. It's pretty cool how we can do that. Alright, what else do we got? So we have y minus 1/2 squared is equal to 2 times x minus 5. Alright, so y minus 1/2 squared equals 2 times the quantity of x minus 5. Well, let's find the vertex first. Set that x minus 5 equal to 0, you would get x equals 5. So the x coordinate of the vertex at 5. Now set that y minus 1/2 equal to 0, you would get y equals 1/2. So the vertex can be found at the point 5, 1/2. So 1, 2, 3, 4, 5. There's 5, 1/2 right there, roughly. Okay. Now that we've done that, let's find p. So set 4p equal to 2, you get that p equals 1/2. Okay, so we found our p. Now, which variable is linear? It's x, right? That's the linear term. That means it's going to have x-axis symmetry. And furthermore, since the P is greater than 0, it has x-axis symmetry, this is going to open to the right. So the parabola will open to the right. Okay. Now we need to find the focus. So let's go ahead and find the focus. If we, so it's got x-axis symmetry, that means we need to add 1/2 to our x-coordinate. You would get 5½ or 11/2, and then you leave your y-coordinate of 1/2 alone, so your focus is at 11/2, 1/2. So 5½, 1/2 for your focus, which means we need to find the directrix. Alright, so your directrix, if it has x-axis symmetry, that means it's going to be in the form of x equals something. So if we add the negative of p to 5, so 5 minus 1/2, that'd be 4½ or 9/2. So the directrix is at x equals 9/2. So let's go ahead and plot the directrix here. Let's graph the directrix. And there you go. There's your directrix. So we also have the vertex as well as the focus graphed. Now that we have all that, we can go ahead and start plotting some points. So why don't we pick when y is 0? So if y is 0, that'll be 0 minus 1/2 squared equals 2 times x minus 5. So that would have to mean you get negative 1/2 squared would equal 2 times x minus 5. So then x minus 2 times x minus 5 would equal 1/4, which means x minus 5 equals 1/8, which gives you that x equals 5 1/8. So at roughly 5 1/8 here is where x equals 0. Now what if I pick when y equals -1? Let's pick y equals -1. So that would be -1 minus 1/2 squared would equal 2 times x minus 5, which would end up giving me 2 times x minus 5 equals -3/2 squared, which would give me 2 times x minus 5 equals 9/4. So then x minus 5 equals 9/8. So that means x would equal 5 plus 9/8. So that would be 49/8. 49/8 would end up being 6 1/8. So right about here is where y would equal -1. Alright, now what if we pick y equals +1? So this time let's pick y to be +1. So that would be 1 minus 1/2 squared would equal 2 times the quantity of x minus 5. So that gives you 2 times the quantity of x minus 5 equals 1/2 squared. So then 2 times the quantity of x minus 5 equals 1/4. So then x minus 5 equals 1/8, which means x would have to equal 5 1/8. So you would get 5 1/8, 1. So that's going to put you right about here. And then let's pick y equals 2. We'll do one more coordinate. So again, do 2 coordinates above the vertex and 2 below whenever you have it tilted to the right or left. You know, do 2y above and below is what I would do. So let's pick 2 minus 1/2 squared equals 2 times the quantity of x minus 5. So you get 2 times the quantity of x minus 5 equals 3/2 squared, which means 2 times the quantity of x minus 5 equals 9/4. So that would give you x minus 5 equals 9/8, which would mean x equals 5 plus 9/8. That'd be 49/8, which would be 6 1/8. So at 6 1/8, you also get that y equals 2. I think we have sufficient points now to go ahead and plot this, to draw this. So let's go ahead and draw this parabola here, and voila, there is your parabola with the vertex at 5 1/2, focus at 11 halves 1/2, and directrix at x equals 9 halves. All right. This time I have x minus 1/2 squared is equal to 4 times y plus 3. Okay. So I have x minus 1/2 squared equals 4 times y plus 3. Well, let's go ahead and find the vertex first. So set your x minus 1/2 equal to 0. You'll get the x coordinate of the vertex being 1/2. Now set the y plus 3 equal to 0. You would get y equals -3. So the vertex would be located at 1/2 -3, which would be right about there. 1/2 -3 is your vertex. Okay. So we've established that now. Now let's find our value of p. So set 4p equal to 4, you would get that p equals 1. Alright, so we got a positive value of p. Y is our first power term. Y is a linear term. That means it's got y-axis symmetry. And p is positive. That means it's going to open upward. So this will open upward. Alright, now that we have that, let's find the focus. So, since it has y-axis symmetry, that means we need to take that value of p and add it to our y-coordinate. So if you add 1 to -3, you'll get -2. So the focus would be at 1/2 -2. So at 1/2 -2, there is your focus. Alright, now let's find the directrix. So the directrix is going to be, of course, since it's got y-axis symmetry, it'll be in the form of y equals. Now, you take the negative of p and add it to your y-coordinate, so -1 plus -3 would be -4. So your directrix is going to be y equals -4. So that's going to be right down here. Alright, so we know the symmetry, we know the vertex, we know the focus, we know the directrix, we got all that. We can go ahead and start plotting. So why don't we pick an x value of 0? So let's see here. That would give us 0 minus 1/2 squared would equal 4 times y plus 3. So this would give us 4 times y plus 3 equals 1/2 squared, which would give us 4 times y plus 3 equals 1/4. So that would give us y plus 3 equals 1/16, which would mean y equals 1/16 minus 3. That would be negative 47/16. So that would be negative 2 and 15/16. So negative 2 and 15/16 would be right about there for x equals 0. Right about here. All right. Let's pick x equals -1. So if it opens up or down, pick a couple x coordinates to the left of your x coordinate of the vertex and to the right of the x coordinate of the vertex. That's the best way to get sufficient points. Alright, so let's pick x equals -1. So -1 minus 1/2 squared would equal 4 times y plus 3. So then you would end up getting 4 times y plus 3 equals -3/2 squared, which would mean 4 times y plus 3 equals 9/4. So y plus 3 would end up equaling 9/16, which means y would have to equal 9/16 minus 3. So that would end up being, 9/16 minus 3, that'd be negative 39/16. Or negative 2 and 7/16. So that's going to be a little bit higher up, right about there. And then let's do a couple to the right of the vertex. So let's pick x equals +1. So you would get 1 minus 1/2 squared equals 4 times y plus 3. Alright, so that would give you 4 times y plus 3 equals 1/2 squared, which means 4 times y plus 3 equals 1/4. So then y plus 3 equals 1/16, which would have to mean that y equals -2 and 15/16. So when x equals 1, you'll get about -2 and 15/16, right about there. And then let's pick x equals 2 for one more coordinate. Alright, so x equals 2, so that'll be 2 minus 1/2 squared equals 4 times y plus 3. So that would give you 4 times y plus 3 equals 3/2 squared, which would have to mean 4 times y plus 3 equals 9/4. So y plus 3 equals 9/16, which means y would equal -3 plus 9/16, so that'd be -2 and 7/16 for your y coordinate when x is 2. Alright, so now that we have sufficient points, let's go ahead and plot this here. Let's draw a nice fat parabola, which means it intersects the x-axis twice at some point, but we're not concerned with that right now. So there is the parabola with y-axis symmetry, with the vertex at 1/2 -3, focus at 1/2 -2, directrix at y equals -4. Let's shift this a little bit here now. All right. This one we're just going to do some equations, no more graphing. So they give you that the vertex is at 3, 2, and your focus is at 1, 2. Alright, so your vertex is at 3, 2. Your focus is at 1, 2. We need to find the equation for the parabola. Well, let's establish something. What axis does it appear to have symmetry with? So, what axis appears to be changing? What coordinate changes? So your y-coordinate stays the same at 2, so it's your x-coordinate that changes. That means it has x-axis symmetry. If it has x-axis symmetry, that means to the right of your equal sign, it's going to be x equals, which means your y term would be squared on the left-hand side of the equal sign. Now, if your focus is 1, your vertex is 3, that means because to get your focus you have to add p. Well, that means p equals -2, right? If you're adding p. So we need to find 4p then. 4p would equal -8. So now we know the coefficient outside of the x is -8. Now all that's left to do is take your vertex. If your vertex is 3, 2, well, that'll be x minus 3 on the right-hand side. And then your y-coordinate is 2, so that would be y minus 2. So what you really should get here is the equation y minus 2 squared equals -8 times x minus 3. That's exactly what you should get. Alright, so this time we have a vertex at the point -1, 2. We have a focus that is located at -1, 0. Okay. So the vertex is -1, 2, the focus is -1, 0. So what coordinate stays the same? It's x, which means there's a change in y. So there's a change in y, that means it's going to have y-axis symmetry. Which means to the right of your equal sign, you're going to have some form of y minus something. That'll be your linear term, which means to the left of the equal sign, it's going to end up being x minus something to the second power. Okay. Now, if the focus goes from a y-coordinate of 2 to 0, that means your p is -2, right? So take 4 times p, you would end up getting -8. So the -8's the coefficient on the right-hand side. Now just deal with your vertex. So if your vertex, the x-coordinate's -1, x minus -1 would actually be x plus 1. Then your y-coordinate's 2, this would be y minus 2. So what you should get for the equation would be the quantity of x plus 1 squared equals -8 times y minus 2. Alright, let's change this a bit. So the vertex this time is at 0, 4. They give you the vertex. Then they give you a directrix. So the directrix is going to be y equals 2. Okay. So the vertex is 0, 4. The directrix is y equals 2. In a way, this is easier, because the directrix of the equation will always give away your axis of symmetry. So that means to the right of the equal sign, you're going to have some form of y minus something. And then that means to the left, you'll have x minus something to the second power. Okay. Well, here's the thing. So the vertex is 0, 4, y equals 2. The directrix is always the negative of p, right? That means the negative of p equals 2 because you went down 2 units. Yeah, so negative p is 2, so that means then that your p would have to equal negative 2. So now if you take 4 times that p, you would get negative 8. So good, we found our coefficient on the right hand side. So now that we know the p, we know the axis is symmetrical to. Let's take the coordinates here. Well, good news is your x-coordinate is 0, so really this could just end up being x squared, because x minus 0 squared is just simply x squared, right? But your y is 4, so that ended up being x squared equals negative 8 times y minus 4. You know what? I know what I did. Hold on a second. Disregard that. I see what I did. When you're working backwards, hold on a minute here. When you're working backwards, it can be confusing sometimes. So it's an easy mistake to make, alright? Yes, it's true that it's going to be some form of y equals. And your directrix is y equals 2. So you went down 2 from the vertex. That means your negative p equals negative 2, since you always go down for the vertex then in this case, or it's the negative of p is your directrix. So that would have to mean p equals 2, which would really mean 4p equals positive 8. So you'd actually get positive 8, and then y minus 4. Okay, I see what I did there. So x squared equals 8 times y minus 4. That would be the equation we're trying to get. So when you're given a directrix, sometimes it's easy to reverse reason and mess it up. Got one more like that, and then I have 2 more after it. Okay. Vertex at this point is at negative 2, 1. We have another directrix. The directrix is what? What is the directrix? X equals 1. The directrix is at x equals 1. Okay, so vertex is negative 2, 1. Directrix is x equals 1. Well, the directrix gives away the axis of symmetry, so to the right of the equal sign, you'll have some form of x equals, which means to the left of the equal sign, it's going to be some form of y squared. Now, let's figure this out here. So x is negative 2, your directrix is x equals 1. Notice you're actually adding to get your directrix. You're adding 3 to get your directrix, so that means negative of p would equal 3, right? Because your directrix is always the negative of p. So that would actually have to mean then that p equals negative 3. So then if you take 4p, you would get negative 12. So your coefficient should be negative 12. Now what's your vertex? Well, your x-coordinate's negative 2, x minus negative 2. This would actually be x plus 2. Your y-coordinate's positive 1, so this would be y minus 1. So the equation you should get would be y minus 1 squared equals negative 12 times x plus 2. Alright, 2 more problems here, and they're different yet. They are different yet. So this time they're giving you that the focus is at 2, 2, but they also give you the directrix. What is the directrix? That's going to be x equals negative 2. Alright, so the focus is 2, 2. Directrix is x equals negative 2. We do not know the vertex. We don't know that at all. But the directrix gives away the axis of symmetry. So that means to the right of the equal sign, it's going to be some form of x to the first minus something, which means your y minus something squared will go on the left-hand side of the equal sign. That much we can establish, but what is true about the relationship between the focus and the directrix? That the vertex is in between those. It's exactly halfway between the focus and directrix. So that means we need to find the center. You could think of the directrix as having a coordinate of negative 2, 2, right? You could think of it that way, even though it's really the whole line x equals negative 2. That'll help you find your vertex. So if we remember the midpoint formula, we can find the vertex. So the midpoint, of course, is your x1 of 2 plus your x2 of negative 2. So 2 minus 2 over 0. Then your y2 of 2, or your y1 of 2 plus your y2 of 2. So 2 plus 2 over 2, which would end up giving you, whoa, that's not what I wanted. That would end up giving you 0 over 2, 4 over 2. The midpoint is your vertex. That means your vertex is going to be at 0, 2. Vertex is at 0, 2, since it's halfway between the focus and directrix. So really, we don't even have to do parentheses with the x minus something. If x is 0, it's just simply x. But the y, that would be y minus 2. Now, we need to figure out the p. It's easier to use the focus to figure out your p. If you go from 0, 2 to 2, 2, that means your p is 2, right? So that means 4p equals 8. So you should literally end up getting that y minus 2 squared equals 8x. That would be the equation you get. Y minus 2 squared equals 8x. I got one more, and then we're done with the lesson. Alright, what about the focus is 0, 0, so don't mistake that for the vertex of 0, 0. The focus is 0, 0. Your directrix is y equals 4. Alright, so the focus is at the origin, the directrix is y equals 4. Well, that gives it away then that we have y-axis symmetry, right? So that is y-axis symmetry. So what does that mean? that means your y to the first term will actually go to the right of the equal sign. So it'll be y minus something, which means your x minus something squared goes on the left-hand side. Okay. Again, what is true about the relationship between the focus and the directrix? That the vertex of the parabola is directly halfway between them. And there's a change in the y direction. So that means then, since y equals 4, you could literally go from, let's see, 0, 0, then you could make your directrix coordinates 0, 4. You can make your directrix coordinate 0, 4 for the purposes of doing the midpoint, which is really your vertex. So the midpoint, take your x1 of 0 plus your x2 of 0, divide that by 2, take your y1 of 0 plus your y2 of 4, divide that by 2, which would end up giving you 0 over 2, 4 over 2, which simply then means that your vertex is going to be at the point 0, 2. 0, 2 is your vertex. So what does that mean? That means then that you're going to have the x minus 0 squared. That would literally just be x squared. So that made the left side easier. That would just be x squared. Now if the vertex has a y coordinate of 2, you'd have some form of x squared equals y minus 2. But we're not done yet. You got to find the p. Well, if you go from the vertex of 0, 2 to focus of 0, 0, that means your p equals negative 2, right? So if you take 4p, you would get negative 8. They sure love 8 in these exercises. So that means the equation you should get is that x squared equals negative 8 times y minus 2. Alright, so that is it for this lesson. The next lesson we're going to talk about circles. And we could probably do circles all in one lesson because those are honestly the easiest type of conic section. So we're going to do circles next. After that we'll do 2 lessons on ellipses. Then after that we'll do 2 lessons on hyperbolas. So I will see you all next lesson. Have a good night. Thank you.